Hey y'all, today we're going to talk about exponents and scientific notation. So let's go ahead and get started. Looking at our note sheet on exponents and scientific notation, we're going to go over some of the exponent rules. Now remember, the rules apply when your bases are the same. So let's start working through a few of these. When you are multiplying like bases, you add the exponents. So x to the a power times x to the b power would be x to the a plus b. So let's try an example like that. 2 to the second times 2 to the third. You keep your base of 2 and you add your exponents. 2 plus 3 is 5. So 2 to the 5th power. Or if you want to break that all the way down, or possibly you have a select all that apply, what is 2 to the 5th power? If you're unsure how to do that on a calculator, you're going to type in 2, the power button, 5, enter, 32. So 2 to the 5th power, or 32 if it wants a whole number. When you're dividing like bases, x to the a power divided by x to the b power. When you're dividing like bases, you keep your base and then you subtract. So a minus b. Let's try one. 7 to the 6th divided by 7 to the 4th is 7. Keep your base. 6 minus 4 is 2. So 7 to the 2nd power. Or on a select all that apply, 49. What about a power to a power? So see how there's a power on the outside of this? You keep your base, and then you multiply the outside power by the inside power. So A times B. Look at the example. Keep your 2 as your base, 3, the outer power by the inner power. 3 times 2 is 6. Again, on a select all that apply, that would be 64, 2 to the 6th power. Okay, what about integer exponents? If I have a negative exponent, don't forget the rule of a negative exponent, not the base, the exponent. You need to turn it into a fraction, 1 over x to the n, and it loses that negative. So looking at our example, 7 to the negative 2nd, 1 over 7 to the 2nd, or that also would be 1 over 49. Now, there is another exponent rule. I would like for you to write it in at the top, the 0 power rule. So anything to a 0 power. What if we have 3 to the 0 power? Anything to the 0 power equals whole number 1. Not the base, it equals a whole number 1. Okay, so let's talk now about squares and cubes. A square raises a number to a power of 2. A square root is the inverse of squaring a number. So when you want to square a number in your calculator, you're going to type the number. Let's try 9. 9, and you want to square that, you're going to type x2 because you're squaring it. Equals 81. But if you want to square root, the inverse, square root that number, you're going to hit second, your house, then your 9. I'm square rooting my 9 now. You're rooting it back down, 3. So let's try. If I'm squaring, I'm making it bigger. Square rooting, I'm making it smaller. You're getting to the root of that number. 9 squared, 81. Negative 11 squared. Don't forget, a negative times a negative makes a positive. So positive 121. And then if you have a fraction, this kind of applies with your exponent rules. Apply that power to each of those. 2/3 squared, well, 2 times 2 is 4. 3 times 3 is 9, so 4/9, because you squared each one of those numbers. Now let's square root this. Let's break this back down. The square root of 81 is 9. Now, could that be positive or negative 9? If you're square rooting it, it could be either a positive 9 or a negative 9. A lot of times you'll see it written like this. The square root of 121, 11. And the square root of 4/9, 2/3. Okay, let's talk about cubing. It's similar to squaring. When you cube something, you are increasing it. When you cube root it, you are decreasing it. So a cube is to raise something to a power of 3. Cube rooting is the inverse of cubing a number. So let's talk about cubes. In your calculator, when you are cubing something up, so 4, you're going to hit that roof button. And then to the 3rd, because you are cubing it, 64. Okay? Let's talk about this negative here. A negative times a negative times another negative, because I'm doing this 3 times, would make my answer negative 1,000. And then 2/3 cubed, 8/27, because it's 2 times 2 times 2. And then on the bottom, 3 times 3 times 3. Cube rooting something. If you're unsure how to do that in your calculator, to cube root something, you are going to type the 3 first. Then you're going to do the special house that has the X with it. Then type your number, 64. So the cube root of 64 is 4. Let's try that again. The 3 first, then the special house, then your number, 1,010. And the cube root of 8/27, 2/3. All right, let's talk about scientific notation for a little bit. A value written as the product of a number between 1 through 10 and a power of 10. So your first digit before the decimal can only be 1 through 10. So 1 through 9 there. You can't have 10. It would be used as a 0 there. Now, a power of 10, you're always going to have times 10 to a power. Let's go through a few of these. If you need help changing your calculator to scientific mode, second, DRG, scroll over to Sci, hit enter, and now you'll know you're in scientific mode because the Sci pops up. So this says scientific to standard. When you want your answer in standard form, you always want your calculator in regular mode. So you can reset it just like that. Now, you're going to type this in and hit enter, and it will give you the standard form. So 4.235. You can type times 10 and then raise the roof with your exponent, or you can use this EE trick, second, and then EE. That gives you the times sign, the 10, and the raise the roof exponent. So just type your exponent, and then hit enter. And there it is as standard form. 42350 0 0 0. Let's try that one more time. So 6.88. Instead of typing times 10, exponent, up arrow, I'm going to type second E. That takes the place of all of that other stuff, the times, the 10, the exponent button. And then type -7. Now, I know this is a negative exponent, so I know that this is going to be a decimal answer. And it is 0.00000. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6, 8, 8. And that's how you go from scientific to standard. Now let's practice standard to scientific. This is when you're going to want your calculator in scientific mode. So second, scroll over to Sci and hit enter. Now you're just going to type the number exactly as it appears and it will give it to you in scientific mode. 12920. Enter. There's your answer. 1.292 times 10 to the 5th. Let's try that one more time. 0.00097. Enter. 9.7 times 10 to the negative 5th. And I know it's negative because that's a decimal. Now, this box is trying to teach you the old school way of scientific notation. You are more than welcome to look into that. However, in 8th grade, you are allowed to use your calculator, so you can enter these in your calculator exactly and it will give you the answer. So, if you want to enter parentheses, that's fine. You don't have to. I like to enter them. 5.3. I'm going to do that little second E trick so I don't have to type everything in. 4, parenthesis, plus 2.6 E for my exponent, close parentheses, 7.9 times 10 to the 4th. And yes, that's what we have. Let's try that one more time. This time we are going to be multiplying because the parentheses are side by side. So parenthesis, 1.2 E 3 parenthesis times another parenthesis 3 E 6 close parenthesis 3.6 times 10 to the 9th. Okay, let's talk about a few things with exponents and scientific notation. So let's flip over and try a few problems. Just real quickly, see if you understand. 5 to the 9th divided by 5 to the 7th, same base, so I'm going to keep it 5. 9 minus 7, 2. 5 to the 2, or on a select all apply, what is 5 to the 2nd? 25. Good. Anything to the 0 power? The answer is 1. Okay, so exponents are pretty easy as long as you remember your rules. Let's talk about a few scientific notation problems and some things that I would like for you to understand. Go ahead and write down, let's look at a few things, and I want you to write this note here in a little bit of space that you have. How much more? Anytime you see how much more and you're dealing with scientific notation, that's going to tell you to subtract. And anytime you're subtracting, you always pull the larger exponent first. The larger exponent first. So if you're reading a word problem and it says how much more, you're going to be subtracting and you are going to pull your larger exponent first, or how many more. Okay? And then if you ever see problems that say how many times as much. Anytime you see times, that's talking about how many times something happens versus another time something happens. So that's going to be division. And you're always, again, going to pull the larger exponent first. Okay? So go ahead and work through some of these problems and see if you can realize where we're going to be subtracting versus where we're going to be dividing. You'll see those problems on the back page here. So looking at 9 A professional basketball stadium can hold 21,000 people. A motor racing venue can hold 8.5 times 10 to the fourth people. How many more people can the motor racing venue hold than the basketball stadium? How many more? So what operation are we going to be doing there? Subtraction. How many more? Subtraction. You would first need to turn that 21,000 into a scientific notation, or turn the 8.5 into standard form so that you have the same increment that you're working with. How many more people? You're going to be subtracting there. Look at number 8. Andrew is in an airport where the largest airplane weighs blah, 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 and the smallest airplane weighs blah, blah, blah. How many times heavier? How many times heavier? Going to be dividing there. I hope this helps. Y'all have a great day. Bye.